Okay, welcome to the introduction to using InproTK. InproTK is an implementation of the incremental processing architecture. You may have heard of this. If you haven't heard of this, then you're not going to make very much sense of this intro, because I'm not going to go over that very much. In fact, I'm not going to go over that at all. I encourage you to read a paper by David Schlangen and Gabriel Scanse called A General Abstract Model of Incremental Dialogue Processing, published in Dialogue and Discourse. That's a good place to start, and there are some other tutorials that you could use for that. But I'm going to assume that you know a little bit about incremental processing and that you are at least partially knowledgeable about what InproTK can do. InproTK is an implementation of the incremental processing framework and hence incremental processing toolkit. It's written in Java, primarily written by Timo Baumann. And though I won't go into too much detail on the inner workings of InproTK or incremental processing, and I won't even really talk a whole lot about IUs, incremental units, that's left for another day. Today we're going to talk about hooking InproTK modules together. And to do that, I do need to explain at least a little bit on what an InproTK module is. And this follows the incremental unit framework of incremental processing, where a module has a left buffer and a right buffer. The left buffer takes input from previous buffers or from previous modules, and it does its processing. For example, a speech recognizer would take audio input here, do processing on it, however that is, and output words on the right buffer. And then other modules that are hooked into the right buffer via their left buffers can take those words, those incremental units, and process those and pass those along on their right buffers, etc. And I need to introduce what an OpenDial module is very quickly, because we're going to be using OpenDial as a dialogue manager. They also are called modules, but they're a different type of module. They also take input, but we're going to call them triggered input, which is sort of like a left buffer. It's going to take input somehow and process it. So you have these two types of buffers, but the main buffer we're going to focus on is the InproTK module. Sorry, the module we're going to focus on is the InproTK module. What we're going to build is a dialogue system that looks kind of like this. You have InproTK as the framework that holds everything together, and you have 1, 2, 3, 4 modules. You have a speech recognizer module, which will take speech input from our microphone, and that is Sphinx, and that is built into InproTK. We also have a head nod module, and this is a really simplified module. It doesn't actually do head nod detection. It's just going to take a nod bit of information from an outside source and then package that up as an incremental unit and send that along to the dialogue manager. So the speech recognizer and the head nod module are going to send their recognized information incrementally to the dialogue manager via incremental units. And the dialogue manager is really made up of two things. This has an InproTK style module, which has a left buffer, so it takes the information, and then it's going to package that information in a way that's usable to the OpenDial dialogue manager system, which is also written in Java by Pierre Lison. And that's going to help us make dialogue decisions. And when the dialogue decision is made, it's going to pass the state of the dialogue to this decision module. And this decision module will then also, it will be an OpenDial module, but it will also be an InproTK module, both at the same time. And so it will have a right buffer, and that right buffer will send incremental units, that is dialogue decision incremental units, to Mary TTS, which is our text-to-speech system, which is also built into InproTK. So, some code. The way it works is we will begin with modules, because we've sort of seen that there are 4 modules. So now I'm going to show you how those work in InproTK, how those fit in, how those are implemented. And we'll just start with the dialogue manager, because the Sphinx speech recognizer and the head nod module are both already built into InproTK. So the first module that we're going to build on our own is a dialogue manager. Here's the dialogue manager. It's actually not very many lines of code. There are two main methods that you need to know about when dealing with the InproTK modules. First, you're going to make a class. You're going to give it a name, and it's going to extend IU module, which is, as you would expect, part of the InproTK incremental system. When you do that, you're going to have two methods that you're going to then implement. And one is called the left buffer update. And this is essentially when you get information on your left buffer. It's going to give you a collection of incremental units and edit messages on how to deal with those IUs. In this tutorial, we aren't going to go over how the edit messages work. We're just going to pass information between modules. And then the other method that you need to write is, well, you don't have to write it, but it's very useful to write, is the new properties method. And this sends what's called a property sheet. And I'll explain what the property sheet is in a little while. But this method is very important. The new properties method is what is called when the system is starting up. So when you are trying to get data structures ready, load some models of some sort of a classifier or whatever, it should be done here. And then everything's ready to go, and then you can start listening on the left buffer in this module for changes. What this module is doing is setting up a dialogue manager, and that dialogue manager is in fact OpenDial. It's called Dialogue System, but it's an OpenDial dialogue system. OpenDial is also a fully fledged working end-to-end dialogue system, but we're only going to use it for the dialogue manager here. So I'm going to start up the dialogue system in the new properties method, and it will begin here. And in each of these methods, I'm going to set up I'm going to output setting up dialogue manager, or setting up whatever module it is, so we can see during startup what is happening. Okay, so all this dialogue manager module does is, when there's a left buffer update, it takes the IUs and steps through the collection of IUs that comes. And if it comes from a word IU, we can assume that it came from the speech recognizer. If it came from the speech recognizer, then we're going to take the payload of that IU, which will be a word, and send it to the dialogue manager. And we're going to do that through this update state method. So if we follow the update state method, we get to here, and we're going to just basically, it's very simple here. We're going to system.add content, and we're going to assign a variable to the value. In this case, it's going to be the speech variable to the value of whatever the word is that came from the speech recognizer. If we happen to receive a type of incremental unit that is called a sensor IU, then we're going to assume that comes from the head nod module, and we're going to do the same thing as we did with speech, only we're going to update the state. We're going to assign the head nod attribute the value of whatever comes from the head nod module. And the dialogue manager will then make a decision. And I'm going to show you how that is done. The way the dialogue manager works is it has a set of XML files. And we're just going to use this one file here called the decision.xml file. And if you noticed in the dialogue manager, if we go back to the dialogue manager, it loads this XML file via this domain property getString, which I'll explain in a minute. But it loads this decision.xml file, and it reads this, and it finds these models. And you'll notice that this model can be triggered when this variable is updated in any way. When new input comes in, then this will trigger this. And if you remember from our dialogue manager, we had two variables that could be assigned with the speech variable and the head nod variable. So if we go back to here, we have the speech variable. So if the speech variable gets any kind of update, that is, if it gets a new assignment, then what the dialogue system, what the dialogue manager, OpenDial, is going to do is step through rules and cases in this XML file. And we're just going to use this as a simple non-probabilistic way of doing dialogue management. All right, so if the speech, if someone says hello, or hello rather, then we're going to set a new variable, we're going to call that variable decision, and we're going to set it to hello. So in the end, this decision variable is going to be sent to the text-to-speech system, and that is going to utter whatever is in this value here. And then if someone says the word OK, then we're going to set the decision to gut. So the system will say gut. So a very simple thing. If I'm talking, speaking into the microphone when this InproTK dialogue system is running, it's going to listen. The dialogue system, or the dialogue manager, is going to receive all kinds of new updates in the left buffer. All the new words are going to come through here. And then all of those are going to be sent to the dialogue manager. But the dialogue manager isn't going to do anything unless it hears hello, or unless it hears OK. In which case it'll say hello. It will tell the text-to-speech to say hello or gut, respectively. And I'll show you in a moment how it's going to tell the text-to-speech module how to do that. The other input we can have is from a head nod. It's going to be a synthesized, or not a real head nod. It's just going to be information sent from a fake head nod classifier, so to speak. And if the head nod value is nod, then it's going to make a decision, and it's going to say, basically, I recognize that you nodded. So very, very simple dialogue management. It can only really do three things. It can say hello, gut, or nicken, depending on the input. If speech was hello or okay, or if someone, or if a head nod was indicated. So the next part of this is very important to the dialogue manager. So if we go back to the dialogue manager, what I've shown you so far is only this part of the dialogue manager. What I'm going to show you now is this part of the dialogue manager that makes the decision. So after this stuff is inputted and that XML file has been, the rules in the XML file have been followed, it's going to set this decision variable to a value, either hello, gut, or nicken. And when that decision variable is changed, that represents really a change in the state of the dialogue manager in effect. And what that then is going to do is going to update all of the OpenDial modules. So let me go to back to the dialogue manager. And what we have here is when we started the dialogue manager, we loaded the XML file, and then we started the system. But then we attached this module called Dialogue Decision. This Dialogue Decision module is over here in the code, and I will open it up. The Dialogue Decision module, as you can see, implements module, and this is an OpenDial module abstract class. And so what you get when you implement module is you get several methods, but the method I'm going to focus on is this trigger method. And what this trigger method takes is a dialog state from OpenDial and a collection of updated variables from OpenDial. And what it does is very simple here. We're going to look at the updated variables, and if it contains decision, that is, if it contains this variable, we're going to look at the value. We're going to see if this means it was updated. So if that method was called, it means that the decision variable is updated. Right? Or some variables were updated, and we're going to find out if decision was updated. If decision was updated, then what we want to do is make a new incremental unit. We're going to make it into a word IU, I believe. Yep. It's going to be a word IU, and we're going to fill that word IU with the value of decision. So if decision is, for example, gut, that will be filled into the word IU. And then this is what let me back up. And then it's going to have to put something onto its write buffer, which means it also needs to extend the IU module. So this dialog decision module is both at the same time an OpenDial module and an InproTK module. But of course this module, even though it has a left buffer, it doesn't do anything because the way it gets information into it is through the trigger through OpenDial. But when it sets stuff to the right buffer, it does that in the way that it should do with the InproTK, as InproTK modules do. And that is simply you have a list of edits, a list of these edit messages with IUs, and we're going to add just this one to it, this one thing that in our example says gut, and then that gets set to the buffer, and then in this case we have to notify the listeners. And what's on this thing's right buffer is the generation module. We're calling it generation even though it doesn't technically do a whole lot of generation, it just says what is there. So this is another IU module from InproTK, and as we would expect, it has the new properties method and the left buffer update method. The new properties method, all it does is it prints out setting up generation, and then it sets up the speech dispatcher, which is its way of talking or getting Mary TTS set up. The left buffer update does something very simple. It takes, as we would expect, the collection of IUs that are updated, and then it's going to step through them. This one's only going to receive word IUs, and we're just going to take the payload of the word IU, which in this our example was gut, and it will just play it. This method just plays it. And that's all this thing does. It plays whatever was in the decision variable from the dialog manager. So those are our 4 modules, well really 3 modules that we made, but there are 2 other modules. The speech recognizer, which is built into InproTK, and the headnod module, which is also built into InproTK. And now I'm going to show you how all these things are hooked together. And that is through the config files that InproTK requires. There are several config files, but the one I'm going to show you is the IU config file. This has very minimal information in it. What it's going to do, what this file tells us is how the network, the IU network is built and how the modules are connected to each other. Rather, what modules, when something is put on a module's right buffer, what other modules will get it on their left buffer. So if we start with the speech recognizer, that is right here. If we scroll down a bit, it's called current ASR hypothesis. And on its right buffer is the dialog manager. I want you to ignore this next one for a moment, but on the right buffer is the dialog manager. And the dialog manager, which goes to DM, will then receive updates from the speech recognizer. That's this, the dialog manager, which was our code that we wrote here. That's this class right here. Notice it doesn't have anything on its right buffer, remember, because it is only an InproTK dialog, it only receives information on its left buffer. The decision module is going to have the right buffer. So the decision module is here, and it will pass its stuff to the synthesis module, and the synthesis module, I believe, was up here. Right, here's the synthesis module, which is module.generation, which is our generation module code that I just, this InproTK module that I just showed you, and that will play the audio. So, but the inputs, again, we have the speech recognizer, and we also have the head nod receiver, what we would call it, which is called, where is it? The head nod listener, which is another module that's built into InproTK. And all it does, this module has takes information from something called the robotic service bus, packages that up and sends it to the dialog manager. So the dialog manager, as in our little graph here, our little chart, gets information from the speech recognizer and the head nod gesture, I guess, head nod events. And so here's that head nod event maker. It's actually, so the robotic service bus is a way to send information to and from processes that can be on the same computer or on different computers. And here I have a simple little bit of Python code that will start up what's called an informer, and then I will send a nod event. Notice that this nod event here has this spelling, which is important because in our dialog decision, when head nod receives this event, then it will then say the word importantly. So, okay, so you have your modules, you have your configuration that hooks all the modules together. You have your decision XML file, which is for OpenDial. Now what we need is a way to start InproTK and load everything and get everything running and actually run your dialog system. We're going to go over here to app, and I've made this class called main. What main does is it runs this run. Let me just start from the beginning. It's a main method here, and that will just run main.run. So if we go to main.run here, this sets some properties that are important for MaryTTS. And then what I am going to do is load this XML file. This configuration manager is part of the InproTK. Technically it's part of Sphinx, but InproTK is going to use this to load the configuration information. And then it's going to get what's called the property sheets, and these are information, the bits of information that are here when you define a module in the XML file. So it's going to load this, and it's going to set up the listeners, and really that's it. If you don't know exactly what all of this is doing, that's okay. You just, in order to run InproTK, you have to load the configuration, you have to set up the property sheets, and then you have to get the modules that are the input modules and turn them on, and then what will then happen is the modules beyond that will start up. So this loads up the ASR hypothesis module, the current ASR hypothesis module. It loads that, and then everything that's in the write buffer of the current ASR hypothesis will begin to load, like the dialog manager, and then in turn the synthesis module, or the generation module, excuse me. And then this turns on the microphone. This turns on the Sphinx speech recognizer, which will then recognize from the microphone, and that will make incremental units out of words that are spoken into the microphone and give those to the dialog manager. So there you have it. You run this, and it will load up all of these modules that I showed you, and then it will be waiting for input. So I'm going to go ahead and run this. It's going to take a minute to run. You're going to see down here what's happening. It runs a little slow because we are doing this recording. So it's going to set up the dialog manager. It's already set up the speech recognizer and the head nod classifier, or the head nod module rather. Yeah, OpenDial has this little GUI. We're just going to close that. It's setting up the generation. Generation is going to take a little while again because we're making this video. It's eating a lot of resources for this computer, for this MacBook, and it takes a while anyway. There's a lot of stuff, models and things that are loaded when the generation is being set up. Here we can input text if we want to, but we're going to use speech, and now it's loading the speech recognizer. Don't worry about the red stuff, that's just information, it's not errors or anything. And I'm going to say I'm just going to start talking, and then when I say the words okay or the word hello, you should see in the console the decision that will be made, and I'll show that to you here in a minute. I don't know if you'll actually hear the audio that is uttered by the text-to-speech by Mary TTS. I will hear it, but I'm not sure if the recording will pick it up. Okay, so speech is running, and I'm talking, and it's picking up these words from the microphone, but it's not really acting upon it. Okay, so it thinks I said okay, which means it's going to send GOOT to the text-to-speech, and I just heard it. I don't know if you heard it, but I did. Okay. Okay. I said okay. Okay? Well, of course, when I want to have it work, it doesn't work. Okay, 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 okay. How about hello? Hello. Hello. Okay. Okay. Hello? Well, the good news is the dialogue manager is filtering all this stuff out, so it's not making decisions based on this, this other input. So the dialogue manager is working, even though the speech recognizer might be struggling a little bit. Let's try it again. Hello. Okay. 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 Well, I don't know where it's getting all this audio from. While it's running this audio, and I'm just going to keep talking here, we have our other modality, our head nod modality, which I said was this simple. Oh, there it spoke. It's getting some okays now. It must be running a little bit slow. Got some okays. But like I said, we have this other modality that are head nods. And what we're simulating here is that there's a head nod classifier running on some piece of software somewhere else, maybe even on a separate computer, and that's going to send events via the robotic service bus into InproTK. So I'm just going to go ahead and simulate that. And the way I'm going to do that is just to run this little thing. And then you can see right here, it's going very quickly. Let me go back to it. So let me stop. Let me run it again. Okay, I just heard it say nickname, so it worked. Let me try to find it here. There it is. And it made this, so it made this dialogue decision. Right. So that's really it. You have here a working end-to-end dialogue system that can take speech as input and can have speech as output, with the dialogue manager making some very, very simple decisions. I want to show you very quickly a little bit more about the IU config. The IU config can help you a lot and make things a little bit easier for you when you're doing your programming. So if we go back to, let's find the dialogue manager. So you notice that the dialogue manager had these extra properties in it. It has the domain file, and it has this thing called decision, which points to another thing called decision. But let's look at the domain file first. What this is useful for is if you go into the dialogue manager class, this is what's sent in with the property sheet. So the property sheet has this this information in it, so to speak. So you don't have to hard code this in. You can put this in the config file. So what this is going to do is, I have this property called domain prop, which is a domain file. These things need to be annotated at the beginning of the class. Excuse me. And then if I go to IU config, the domain file is right here. It's that name. And then right here, so this domain file is this domain prop string. So if I go here, property sheet.get string, it will then get this string right here. And that string is a path to this this XML file, which is the information we needed for the dialogue manager to make its decisions. Right, so we get this domain, this XML domain reader. This is all OpenDial stuff, and then that's sent to the dialogue system, and the dialogue system is started. Now for the module, the decision module is right here. and that's simply is pointing to this, which is this module open dialog decision, which is this thing we showed you before. Let me look at that one more time. So here's this code. It has the trigger, it has the write buffer update and everything. And that is then attached as a module here. And that's how that sends information. That's how this gets information from a left buffer update and gives it to the dialog manager. And then the dialog manager then, when it makes a decision, informs the dialog decision module, and then that passes it along to the write buffer to the generation module. Quite simple. But this is how it works. So recap on InproTK modules. You have two methods that are important. First of all, you have to extend IU module, and then you have the new properties method, which is where you set things up. It's almost like a constructor for this. And then you have the left buffer update, which is what's called every time new input is received. As you can look right here, you can see DM received, and I have this here. The DM received lots of these words from the speech, and that's done here. So every time it got a left buffer update from the speech recognizer, it would run this, and you could see that it happened continually because we're working incrementally. What I'm not doing too much, I guess, is making incremental units, actually. I'm getting incremental units from the speech recognizer, and I'm getting them from the head node classifier. But I'm not getting into incremental units, and I'm not doing important things like grounding in or same level linking or revoking or committing. I'm just assuming there's always an add here, and there's always, and I don't have to link it to anything. This is not the best thing, but like I said, the take-home message for this little intro was to get you to be able to use InproTK make your own modules in InproTK, and I'll have some later code, or maybe we'll have a later tutorial, or at least a README file that explains on how how you can hook incremental units to each other. But that is it. Thank you for your